All right, sorry. Here we go. Now, for this particular part of the lesson, again, this is not really in the book, but it's something that they took out for some strange reason. So I do think it's kind of important. So here is the rule for segments. Now, chords that bisect. Now, at first, I was a little shocked by why this is even necessarily true. But what I want to do is I will show you how they came up with this. Because to me, it looked a little awkward at first. The rule basically is, and if you want, you can draw yourself a circle. All right, and then we have intersecting chords, right? And then if you call this A, you call this B, C, D. Notice it doesn't say they're a diameter, right? But what they do say is, or it's easily to prove, that A times B is always equal to C times D, right? So the product of the parts of the intersecting chords is always equal. And again, listen, I'm just saying that's another rule for you to remember. All right. It's not that it's a difficult thing, it's just a rule. All right. Now, if you want me to show you real quick why that is true, it is just from the fact that you can construct triangles. And then they realized what's true about those two triangles always. Yes, thank you very much. They are in fact similar. All right, so how do we know they're similar? Remember, this must be equal to this because they share a corresponding arc. Does that make sense, everybody? And then, of course, you could say the vertical angles, right? But the other thing you could is you could then say that this angle right here is equal to this angle right here for simply the same reason that chord or those two angles intercept the same arc. So they have to be equal. All right. So if they are proportional, you will see that A over B must be equal to C over D, and they just cross multiply. So everybody with me on that? All right, so that's a simple technique. All right, so how does that play a part? That plays a part down here because now you can see how simple these are. So you would simply say for question number 1, you would say 23 times X must equal what?
23 times 15.
Thank you, 23 times 15. And of course, we can just look at that and say X must have been what?
15.
X must be 15. All right. Just to make sure, we'll go ahead and do number 2. We'll say 6X must equal 3 times 4. So X must equal what?
2.
X must equal 2. All right. Again, you see, it's really simple. I don't think it's something you can, most kids would not be able to sit and say, okay, why is that true? How do you figure that out? All right. These are all just rules, all right, that you have to know. All right. So now let's look at a little bit harder. Number 4. So for number 4, we would say simply what? 6 times what?
The X plus 5.
X plus 5 must equal what?
12X.
Must equal 12X. All right, now I'm not going to distribute here, right, guys? I'm just going to go ahead and do what? Divide by 6. Is everybody with me on that? So now we have X plus 5 equals 2X. So X must have been what? X must be 5. Everybody good with that? All right, now number 5 is the important one. All right, number 5 is important because it's just a good review of algebra. It's a good review of algebra. So somebody go ahead and set that up for me. Help me. I'm not asking you to do the problem. I'm asking you to just tell me what 2 things multiplied together are equal. Go.
X plus 10 times X plus 1
X plus 10 times X plus 1. Thank you.
equals X plus 13 times
X plus 13 times X. I just don't think that's that hard, right? All right, now, of course, we have to do a little bit of algebra here. So again, I would like to send you off to high school so everybody can look at this and just multiply that in your head. You should be able to do that. The numbers are not that big. All right, remember there is a middle term, correct? So it's going to be X squared, what?
plus 11
Plus 11X
plus 10
plus 10 equals what?
X
Bless you, bless you.
squared plus 13.
X squared plus 13X. Anybody have any issues with how I got 11X? Remember, that's just from multiplying our little smiley faces together. All right, and of course we can solve that nicely because what happens to the X squareds? All right, so we should be able, everybody should be able to look at that and just say X equals what? Everybody should be able to look at that without doing any work and say X equals 5 and freak out your teachers next year. And they'll look at you like you're crazy. All right, anybody have any questions with X equals 5? Anybody?
No, sir.
All right, I'm pretty happy with that. Let's move on. Now we come to a different rule. We come to a different rule. All right, and this is kind of the same principle. They solve or they create similar triangles. All right, but in this case, please, let me just show you. All right, we say the outside. All right, I'm just going to draw another one up here, and let's let you draw this out. All right, well, maybe not. Here goes the rule. Regardless of if it's a secant or if it's a tangent. So the first thing I'll do is a secant and a secant. All right. So if two secants are formed, I'm going to call this A, I'm going to call this B, I'm going to call this C, I'm going to call this D. All right. I learned it as the outside part times the entire length. What's the entire length of the secant? A plus B must equal the outside, which is C, times the entire length, which is what? C plus D. That's the rule. All right. And if you want, you can say those are two secant lines. All right. Those are two secant lines. So the outside times the whole part is equal to the outside times the whole part. All right. Now we have what's referred to as a secant and a tangent. So the first thing I'm going to do is draw a tangent. And then I'm going to draw a secant. All right. So again, I'm just going to say that's A, B, C. Is there anything different? And the answer is no. The outside times the whole part. What is the whole part? Exactly. Equals the outside, which is what? Times the whole part, which is B plus C. Guys, that's just a rule. All right, that's just a rule. All right, anybody have any questions? Kind of like the other one. All right. Anybody? Again, now it's just, can I plug in the numbers? All right, that's all I'm asking you to do is plug in the numbers. So number 7, what's the outside? What's the whole length?
3%.
Yeah, but I would say X plus 3. It doesn't matter, right? Equals, what's the outside? Times the whole thing? 2 plus 10, which I'm just going to go ahead and call what? 12. Now, am I distributing the 3? No, I'm dividing by 3. So do your mental math, practice your mental math, and then tell me that X is equal to. What do we got, guys? 5 is what I got, right? Because I divide by 3, I get 2 times 4 subtract 3. Everybody's good? So X must be 5. All right, so let's check out number 8. So what is the rule for number 8? 5 times 8 equals 4 times X plus 4. So everybody, please look at that. Practicing your mental math. X equals what? X equals 6. I'm expecting everybody to be able to look at that and just say, that's just 6. Everybody good? Any issues? All right, just rules, guys. Let's see if there's anything harder. All right, let's look at 10. Now they're asking for RT and TV, so I want to be careful. All right, so I need help setting up number 10. What do we got? 8 times,
8 plus X plus 3,
which is what?
X plus 11.
Thank you. X plus 11 equals 10 times,
Minus 7, or X plus 7.
anybody agree with that?
Yeah.
Now here, I don't really think there's easy way. I mean, we could divide by 2, but it's not a big deal. So here we go, 8X plus 88, right? Equals 10X plus what? 70. Now I have 2X is equal to 18, so X must have been what? X equals 9. So now that X equals 9, we want to find RT, right? So RT is this long thing, right? So what is RT, guys? Right. So RT equals 20. Isn't that cool? Now you can write in pencil. I know I keep being dazed by notability, right? And then TV, let's help me with TV. TV is what?
16.
Anybody agree with that? 16. All right, I'm pretty happy with that. All right, I'm trying to find something that might be a little bit harder. Nothing there. Nothing there. Okay, let's look at 13. Let's set 13 up.
Would be 10 or 100.
Yeah, now again, I don't mind you saying for now, 10 what? 10 squared, right? 10 times 10 equals what? 5 times, yeah, X plus 5. So once again, I'm just looking for everybody to just solve that mentally.
15.
So X is equal to 15. Everybody good with this? Okay, 14 is where we start having a little bit of trouble. Bless. So what do I have on 14? X squared equals what? 9 times 16. Now, of course, we're not going to multiply 9 times 16. All right, because we can just take the square root. And so X is equal to, what's the square root of 9? What's the square root of 16? 3 times 4. There you have it, guys. All right, anybody have any issues with 14? All right, let's find something more complicated. Now, for these right here, all we have to do is put an X in the missing spot. X, X, X. Okay, so let's check out 18. Everybody's looking at 18. All right, so what are we writing or how are we setting this up?
70 squared
70 squared,
equals x parentheses 48 plus x.
yeah, that's what I'm thinking. All right, so now this just required some quadratic work. All right. So this one might be a little annoying. So 70 squared, I'm thinking is, yeah, 4,900 is equal to x squared plus 48x. And now we have x squared. Enough of the pen. So now we have x squared plus 48x minus 4,900 equals 0. Yes.
Why couldn't you like, distribute and then take the square root of x squared and 70 squared?
You cannot take the square root through addition and subtraction. You hear me?
Yeah.
You cannot take the square root through addition and subtraction. You can only take the square root through multiplication.
Okay.
All right. So now we have to try to factor this. All right. Now I'm not even sure if it can factor. So let's see, or let's review our factoring. All right. We know that that's 49 times 100, correct? And remember, I'm trying to find, or I'm trying to calculate the factors of 4,900 that can make 48. All right. So now I'm breaking this down into 7 times 7, and this is 10 times 10. Is everybody with me? And now I'm trying to figure out how to make 48. Right. Now, this again is 2 times 5, and this is also 2 times 5. So I'm taking these numbers. Please listen, because again, it's not always easy, right? I'm trying to take these numbers 7, 7, 2, 5, 2, 5, and trying to calculate to see if there's a possibility that I can make 48. All right. Can anybody see how we can do that? For example, let me show you what I mean. I'm just going to drag this over. All right. What I mean is I have to put these in different combinations, right? So I know 2 times 2 is what? 4. And then I can say 4 times 5 is what? And I can compare 20 with 7 times 7 times 5. And that's just way too big. All right. So I'm trying to calculate different possible values that can come up to 48. All right. And I'm not sure if I can see that. So let's do 7, 5, and 2 together. Yeah. I don't think we can factor it. All right, so because we can't factor it, we're going to try the next step, which is just using the quadratic formula. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, it's just a review. All over 2a. So in this case, negative b would be negative 48, correct? So remember this, a is 1, b is 48, c is negative 4,900. So negative 48 plus or minus the square root of 48 squared minus 4 times 1 times negative 4,900. All over 2a, which is just what? 2. All right, so now somebody type in their calculator 48 squared minus 4 times 4,900. What did you get? Come on, guys, I ask you, I'm just asking, what's 48 squared minus 4 times 4,900?
Negative.
Is it negative? So let's just write this down. Negative 48 plus or minus. What did you get for an answer?
I don't think that's right. Yeah, I got that too.
Negative what?
17,296.
Okay. So because this is negative, or I don't know why they would do this, but because that is negative, all right, there is no solution here. All right, there is no solution. When your square root is negative, there is no solution. All right, so that was kind of a pointless problem. You can't divide it by 2, Sebastian, because underneath the radical. Yes.
Well, could you use them like x plus 98 times x minus 50?
98. Wow, you might be right. Wow, how did we miss that one? That was really good. But still, this should have come out. B squared. Oh, C was negative 4,900. Thank you, David. Very good, buddy. That C was negative 4,900. That was my mistake. The C was negative 4,900. But David said something even more brilliant. All right, let's get rid of this garbage now. Thank you, David. Tell me again, what does that factor to?
98.
Yeah, that was brilliant. So 2 sets of parentheses. And say it again, X what?
98.
X plus 98 and X minus what? 50. Thank you very much. So now X equals negative 98 or X equals 50. Can it be negative 98? No. So our answer is X equals 50. David, thank you very much. Brilliant. All right, so X is equal to 50. So that did factor. We just weren't patient enough. All right, outside times the whole, outside times the whole. Okay, so let's just check 20 since we missed that one. Let's look at 20. All right, on 20, we have the outside, which is what? 20 squared is equal to the outside times the what? Which is what? X plus 42. So now we have 400 equals X squared plus 42X. And so now X squared plus 42X minus 400 equals 0. So I'm sure this factors. We just be patient. Let's try to figure out what are the factors of 400 that make 42. What is it? 50 and what? Wow, very good. So it's be X plus 50 and X minus 8. Thank you, guys. And so my answer was X equals what? 8, right? We don't even have to worry about the positive 50 because that will give us a negative length. All right, let's keep going. I want to do 23 now. All right, come on now, you guys. This is practicing your algebra. All right, that's all we're doing is practicing algebra now. All right, so let's set up 23. 23 is going to be what? Now, when you say 3x squared, how should you write that? Yes, in parentheses, 3x squared equals,
Times 2x plus 10.
right, 2x plus 10. All right. Now 3x squared becomes what? 9x squared equals 4x squared plus 20x. All right, that one's a little bit better now, because now when we set it equal to 0, we end up with what?
5x squared
5x squared
minus 20x.
minus 20x equals 0. So what's the GCF here, guys?
5x
5x. We end up with what?
x
X what?
minus 4.
Minus 4. Is it possible for x to be 0? No, because there wouldn't be a tangent line. So the only possible answer is x equals what? GCF, right? Hold out a common 5x. Are you having trouble with 5x equals 0, Sebastian? Let's just go ahead and do 26. Let's do 26. All right. So, yeah, come on, set this up, someone.
X plus 2, but this is
X plus 2 times.
2x squared.
No.
X minus 8.
Come on, guys. Somebody said 3x what? Remember, you're adding them. Outside times the whole length. Come on now, outside, right? Times the whole length. All right, get the next one right.
X plus 1, and then this is 3x minus 4.
Yes, there you have it. Outside times the whole length is equal to outside times the whole length. So here we go. Good algebra review. Good algebra review. So here we go. Multiply. What do we end up with?
First one's 3x squared.
3x squared. Now remember the middle term. Do the mental math. How much is this?
Cancel.
Oh, is that nice? They cancel, right? Minus 12. Good job. Equals.
3x squared. And then this is minus 1.
Minus what? And then what? Now, come on, guys. Don't let everybody else do the work. All right. If you don't understand how it's 3x squared minus x minus 4, it'd be helpful if you. But the other thing is, I'd like for you to try. Right. Remember, when you're multiplying, there's a smiley face. These two multiplied together and these two multiplied together. Right? 3x and negative 4x is negative 1x. X times 3x is 3x squared. 1 times negative 4 is negative 4. Anybody have a question with that? Aiden, what?
How does 2 and 3x cancel out?
Did you multiply them? What is that when you multiply? Come on, Aiden. What is that?
You multiply as 6x.
And what happens when you multiply this?
Oh, that's minus 6.
Come on, it's the same thing. Now, what happens to the x squareds? They cancel out. So if we do our mental math here, we can all look at that and say, then that's good work because x equals what? Negative 8 or positive 8? I think it's positive 8. Is that correct? All right, x equals 8. Okay, so let's take a look at 25. I like that one. What's 25? 3x minus 3 times what? X. equals 2x times x plus 6. All right, come on, do the algebra. Let's see how good you are. Yeah, some of you will be sitting back in Algebra 1 next year if you're not careful. You don't want that. So you should make sure you know how to do these. When I distribute the x, what do I get? 3x squared minus 3x is equal to 2x squared plus 12x. Anybody have any issues with that? So now say that again. X squared minus 15x equals 0. Is everybody with me on this? GCF is what? Is it possible for x to be 0? No. So x must have been what? 15. Now let's just see if we're right. All right, just to double check. If I plug 15 in, 3 times 15 minus 3 is what? 42. So I'm going to put a 42 right here. Then I'm going to put a 15 right here. And what's 42 times 15? 630. Is that right? And then over here, I've got 21 times 30. And guess what 21 times 30 is? Yeah. So we know we did that one correctly. All right, the product of the parts are always equal. What's 43 times 10? Right, then, no, I'm sorry, 42 times 10. 400, what's half of 420? What's 420 plus 210? Because anytime you multiply by 15, you multiply by 10, divided by 2, and add it. All right, that's an easy way to multiply by. Okay, now, what time's the bell ring today? What is it? 41. Because of the, yeah, today we're on normal schedule though, right? Yeah, so it's on it. So we have advisory. So my question is, if it's normal, do we normally get out at 41?
Yes.
All right, so let's do this. Since it's 35, we have 6 minutes. Because some people are in the mock trial, which I think is a really cool thing. We will finish this up tomorrow and we'll let them get caught up with us tomorrow. All right. Yeah, no, I don't care. We're good. And then tomorrow, that means Monday we'll review chapter 9, and then Wednesday we'll have a test on chapter 9. We have one more chapter left, guys. I'm super excited. And then we will be having our exam. And then we will be doing Algebra 2.
No.